Okay, so let me shortly introduce you. My name is Gernot Hogg. I'm working in the Center of Expertise for Exoscale. The Center of Expertise, those are the pre-sales guys behind our sales guys, so doing the technical stuff for the sales guys. And we are 5 people helping customers in the pre-sales phase, but also during the post-sales phase and the snippet, for example, which is the debug filter that's coming from one of us. So Dennis wrote that snippet because out of customer requests, and those things we are doing. We also, in the Center of Expertise, we also try to keep it simple because we have just 4 or 5 people. We try to keep it safe as we are dealing with customer data or helping the customers, and it should be scalable. So if you're finding a solution or having a possibility to do something, we try to scale it also to other customers. So there's the snippet for the debug filter. We have a snippet for adding routes to an SKS cluster. So we try to reuse the stuff we have and use that. The next 20 to 25 minutes, we're gonna move over to a GitHub web page and we'll provide a live demo. And I hope it's going a bit better than the demo from Lucas today in the morning. But yeah, let's see. The last time it worked, we were testing it in Munich. The first time it worked. I was testing it a couple of times this week. It always was working. So let's hope nobody's doing deployment in the background, so that is working. And let me just switch over to the GitHub page and get over there. That's our GitHub page. So what we're going to do is we're going to deploy a simple sample application. But the application has a meaning for us. In the end, everybody should be able to order drinks for the coffee bar upstairs. And the deployment is taking, let's say, 5 minutes in total. And we're going to go into some details of our application. So the application is in 3 parts. So we have a backend application. We have some front end, which is written in Node.js. We have some Terraform scripts, Kubernetes stuff in it, which we're going to use. And let's scroll down. We have a similar picture to that from Gordian. So we have our architecture is we are using the Exoscale DNS. So we need to propagate some DNS records to the internet. We're going to use the network load balancer of SKS to get the traffic into the cluster. We're going to provide some ingress rules for our cluster because we have a backend and a front end. The backend is not secured in that case. So if anybody knows the URL from the backend, he could look into the database and see which drinks are ordered. That's the purpose of the demo, so don't use it for production. We are using some Kubernetes workers on Exoscale. That's an instance pool with three nodes. And we're going to use a Postgres database, a database database, to store all those transactions in the database and to know what was ordered and to use that. Let's get into details. The front end and back end, I will not talk about a lot about the front end and the back end. It's a Node.js application. It's Dockerized, so we built the images. For the beauty, we are using another Exoscale product, so we're using the container registry from 8 Gears. So we're storing all our images. Sorry. Let me log in again. So we have a public available registry with some applications, and in our case, I just needed to modify the demo for the Zurich event because we have different drinks at every event, so we have different containers for that, and we are just pulling that container. The beauty of that of the hardware registry in that case is, so if you're not familiar with Docker and all the build stuff and how to push it, you get quite simple examples how to do that, and that's super easy because when you're not doing it in every day, at least for me, the Docker syntax is not always the easiest one. So that you need to tag an instance, that you push it to the right registry and that stuff. That's not always intuitive, I would say. So back to our system. Okay, we have the backend application. Now we're coming to the funny part. So as we are using Terraform and infrastructure as a code to deploy that stuff, we have some scripts, some easy scripts and some some variables to define. So there's one thing, which is, just let me make it a bit bigger. We just need to define some variables for our project. We give all our deployments a project name that's just a unique name to separate the instances in the UI, to get a common feeling for that. Then we need some API keys from Exoscale. We're going to provide some Postgres username and Postgres password, which we give over to the Even database as a service to get it back. We define a zone where we want to deploy it, so that's up to us. And because my demo environment is not hosting its own DNS zone, I need to use a second one from us. That's the reason why I have two different Exoscale API keys, but that's working in a Terraform script. So you can use in Terraform multiple providers from the same origin and use it with different credentials so that you can split up your deployment to different organizations, different security guards, and so on. And when we go through the typical part of the Terraform part, that's, in my opinion, Terraform is quite readable. So if you're familiar with English, I think everybody can read what's on the page. So we are saying, okay, we're going to create some Exoscale security groups, multiple security groups and multiple rules. We're going to deploy a SKS cluster. The cluster is depending on some prerequisites which we need, like the security rules. We're going to make a node pool with 3 instances on the standard medium size. We're going to deploy the Even database, where we use the credentials from which we're setting in the variables. What we need afterwards, we need to retrieve the kubeconfig, because that's unique for our cluster. As soon as the cluster is up and running, we will retrieve that kubeconfig from the Terraform resource, and we'll use it in a kubectl so that we can apply our YAML scripts and our configuration to it and get all that stuff running. We have our Postgres database where we define, okay, that's a Postgres. In that case, it's a startup 8, so it's a not so big database. We want to have a maintenance window on Sunday at 11 p.m. In that case, I disable the termination protection. For production use case, I would everybody advise to enable it, because then you cannot just delete the database. It's a two-way action, so you need to enable. So you need to remove the protection, and then you can delete it, which is which means you need to think when you're doing it. It's not just one click and it's gone. And yeah, I'm just defining the version, and in that case, we are not using the dbus filter snippet. We're just saying, okay, in that case, everybody can access our database as long as it has the password and the credentials and the username. That's fine, but in production use case, use the snippet to do that. After the creation of the database, we need to retrieve the Even URL we get for the database from the database and our password, which is hopefully the same which we provided the API. And so we're getting that out of the URL, out of the secret. We need to provide that to Kubernetes so that we can run our application, which needs to connect somehow to the database again. And yeah, then the next steps are some steps we need to do in Kubernetes. So first, we need to create a secret for the database connection in Kubernetes, and then that's a limit. I wouldn't say it's a limitation. So on the Even side, when Exoscale is sending an API request to Even, that's always asynchronous. So Even says, okay, we created the database, but in the background, when you're checking if the database is created, you're seeing that it's rebuilding in the status of the CLI comment. And the rebuilding means it's something is happening with the database. Either it's a fork happening, or when you're starting it, it's more or less the startup of the database and creating all the replicas. So that's the reason in that case why we say, okay, we want to sleep for 100 seconds, because we know that the database setup takes roughly a minute, something like that. So that's a security point, because what we need to do afterwards, we need to prepare our database. So in that case, we're using a predefined SQL script, and we'll shoot it against the database so that we populate some tables and some schemas. And if we would not wait, the database would not be available. We would get an error, which would mess up our pipeline. and that's the reason why we do that. And then we're starting our Kubernetes deployment. So we're going to use our kubectl with the kubeconfig we got before and just install or configure our ingress in Nginx controller. And then we're just waiting because it needs some time that gets up for 30 seconds. And afterwards, as soon as the ingress controller is up and running, we're going to deploy the application. And that's the moment where we need to wait a bit because deploying the application will tell the ingress controller, hey, I have an application which is coming from ingress controller, and the ingress controller will talk to the Exoscale API and will say, dear Exoscale, I will need a load balancer. We'll populate that load balancer with all the configuration. And load balancer setup takes about, depending, 60 seconds to 2 minutes during the test which I observed. So that's the time frame which I've seen. So we need to wait for the load balancer and grab the IP from the load balancer. Because the last step, and that's the one which is not in that file, the last one is we need to get that IP address from the Exoscale load balancer, and we need to populate some DNS records in our account. So that's the goal of the demo. And if everything goes right, we should have in, I would say, 5 to 10 minutes an application up and running, which should be available and should be accessible. That's my Exoscale demo account. It's a complete empty account. So we have no instance pools, no SKS, no templates. I just have a default security group, which is there automatically. I have no load balancer, so that's completely empty. The only thing which I created in advance is an IAM key. This key is an unrestricted key, so it can create all the resources in that organization, and we'll do the magic in the background afterwards. And yeah, so let's give it a try. Okay, so what I did before, I did a git clone from our repository, and that's inside here. And what I will do now is, those are the same scripts like on the GitHub side. What I do now is the first step is I will do a Terraform init and will tell Terraform, check my configuration, check which providers I will need, and retrieve those providers. The good thing is Exoscale is, since 2 years, officially an official provider from HashiCorp, so you don't need to take care. As soon as it finds Exoscale, it retrieves the actual version, install it, configures it, and it's able to run and use it. So okay, the first step was successful, so we have a working Terraform environment which should have all the providers and should be able to do this stuff. The next thing is, just for security reason, you can do a Terraform validate and check if you have no syntax error stuff in that. That looks okay. So we are fine. And the only thing what we need to do is we need to populate those variables. So because those variables we need afterwards, the deployment needs them during the deployment. So what I did, I just created a Terraform variable script, which just defines those variables. There you can see I just gave the project a name, so it's acceler8. Those are my API keys and my API secret, my AVM username, the password for the database. We're going to deploy it in Zurich that time, so that's the thing. And we have the DNS API keys for the second organization. And if everything goes right, we're going to start the deployment. And we'll see what Terraform will tell me. So Terraform now tells me, okay, you want to add 20 resources, either to the Exoscale or else. We have some comments which are running. Those are also resources. So we have 20 tasks to do. So let's start it and keeps the finger crossed that it's going to work. So Terraform is now doing the magic, starting to figure out the dependencies of the resources, so which resource is depending on what, trying to optimize the flow, so as much as resources which can be populated in parallel will be populated in parallel. And some resources depend on each other, like we cannot create an instance pool for the SKS as long as no SKS is up and running, so we need to wait for that. So now it should take I would say 2 minutes as soon as the cluster is up and running. And then we can check in the UI and see what's happening in the background. So what's happening in the background? So we're seeing, okay, we have an SKS cluster that's getting deployed. It's running in Zurich as we wanted to have. We got one security group that was defined. We have some rules included. Those are the default rules you can find on the community website for an SKS cluster. But we have no instance pool right now, so probably the deployment is still running of the Kubernetes cluster. That should finish probably in a few seconds. Come on. Normally it takes roughly 2 minutes for the deployment of the SKS. So it should be, if it's on time, should finish in a few seconds. Okay, so we have a Kubernetes cluster up and running. In the meantime, we get a kube config out of the Kubernetes cluster. We created the credentials for database access in the Kubernetes. And now we need to wait for 100 seconds. That's the time we need to wait that the Avon database is really up and running. And we can connect with the PSSQL into the database to populate the tables which we need. And then it takes, I would say, another minute to spin up the load balancer and to get everything up and running. So we can check now in the background what's happening. Okay, we see, okay, we have a node pool already, which is also taking the name from a project. We probably have a database up and running. It's already running, so that's the good case. We have some instances, some security group, but we still have no load balancers. That one is probably one of the last steps that's going to happen. Come on. Okay, so database is created. You see some lines suppressed or output suppressed to the sensitive value and config. So that's the point where we are injecting the data or the tables into the database. And that, as that's marked as sensitive, we're not outputting it. So Terraform is not showing it on the console, which is good because there are some passwords inside, so maybe not good to show them. Or to have them, if you're using a CI/CD pipeline, then you would have them in the logs of your tool, and which is probably not a good idea. And now we created the ingress controller. So we need to wait to get the ingress controller up and running. In the background, we already see that there's a load balancer magically created from the Kubernetes stuff without doing anything on Exoscale. Okay, now the last step is running. So Kubernetes is up and running. Our ingress controller is created. Now we need to wait that Kubernetes is getting the IP from our load balancer. And we see that it's still pending. It should get this IP address, so 194, 182, 190, and 13. And that will be the address on which our application will be available afterwards in the internet. It's taking some time. And if everything goes right, yeah, it looks good. Okay, the last two steps, those are the steps we created some DNS records for our backend and frontend application. And now give it a try. And let's go to order, cloudSVC.io. So that's the application. We are just published in, I would say, 2 minutes, and let's say 4 to 5 minutes. The application is up and running. What you can do now, so the application is available in German and English. So if your Mac or your Windows is using another language than German, you would get the English web page. You will have to enter a nickname, and then you can choose your favorite drink. You just need to click. It will show up what you ordered. You can change it every time. It will just change. You do not order multiple drinks. It will be always on your name, which you're doing. As I said, that application has multiple endpoints. So if you are going to question mark par, you would see what the bartender will see. So he sees, okay, Gernot ordered 1 cappuccino. And if someone else would order, we would see the other orders coming in. If I'm changing my name, he will still recognize me as one person because we are tracking the person. So we'll get, we see, okay, Antoine, Oli decided for water, and Gernot was changed to Stefan because he knows that's me, because I get a unique ID from the browser. And that's the good thing. And let's go down to /QR. If you do not want to type the URL, you could use that QR code, scan it, and you would get to the order page. The beauty of the demo is, so I was setting it up now in about 5 to 10 minutes. I would say if you're not talking, it takes 5 minutes for the whole step. Everything from that demo is public available on the Exoscale Labs account on GitHub. You can take it, you can use it. It's just a demo showcase what's possible with Exoscale in a short time, using different services which are available either via direct integration, like it's with Even, using SKS, using the container registry we have on the marketplace, and using all that features and putting that puzzles together to a demo which is a simple demo, but showcase what's possible in a couple of minutes. And the other thing what we learned today with Argo CD, and you have the beauty of a Git in the background. So you have all the changes which are there, they are committed, you have a history of it, you see what was changed, and that's the beauty. And in the end, you just get a Terraform part which you can run and which you can also destroy with one command after the demo and can start up a new one. So thanks for your time, and yeah, open for any questions.